number 17, we're going to use these logs that we know to help us get an approximation for the log that we don't know. And of course, this would be without a calculator, because if we had a calculator, we could just type it in. But here we're trying to use some logic to figure out how to get this. So we have log base 5 of 45. That's what we're trying to get. And we know these other logs here. We know the 6, we know the 8, we know the 9. Now, there's one other one that's kind of hidden to us, so to speak, that we also know. We also know log base 5 of 5, because if the bases are the same, the answer is just 1. So we also know that, and we actually need that for this one, because we're trying to somehow factor this 45 into, you know, 6s or 8s or 9s or 5s or some combination of those. So looking at the numbers that we have, 45 can be broken into 9 times 5. So the steps here would be log base 5 equals, or log base 5 of 9 times 5. Then we can use our product property to split this into 2 individual logs. And that's good because then we know what the individual logs equal. So this statement is equivalent to this statement. And then each of these, we know their individual values. So this is 1.4 plus 1. So therefore, the sum would be 2.4. So log base 5 of 45 is 2.4. So it's all about finding what factors that we know will give us the 45. So 18 is very similar. It's a little more straightforward because we can clearly see what the factors are. So if we have the 4 over 5, and we know what log base 4 and log base 5 are, we can apply the quotient property and say this is log base 7 of 4 minus log base 7 of 5. Well, log base 7 of 4 is approximately 0.7, and log base 7 of 5 is approximately 0.8. So the difference of that would be approximately negative 0.1.